Okay, 4.4 part 2. We're going to continue evaluating logarithms and graphing logarithmic functions. We're going to start by evaluating these two compositions, g of f of x and f of g of x. So first, g of f of x, that's the same as finding g of f of x is b to the x power. That means wherever there's an x in the f function, we're going to replace that with b to the x power. So that would be log base b of b to the x power. So to evaluate this logarithm, it means what power do I raise b to, the base, to get b to the x power, which is the argument? What power do I raise b to get b to the x power? In order for these two expressions to be equal, their exponents would have to be the same. So your answer is just x. So what that means is that you're looking for a pattern of the base of your logarithm to be the same as the base of your exponential term in your argument. If those two bases are the same, your answer will always be the exponent. So if you had log base 2 of 2 to the 5th power, since these two bases are the same, your answer is the exponent, which is 5. So look for those patterns. Okay, f of g of x, that would be f of g of x. G of x is log base b of x. So wherever there's an x in the f function, we're going to replace that with log base b of x. F function is b to the x power, so that would be b to the log base b of x. You're looking for the same pattern, b, the base of your exponential term, to be the same as the base of the logarithm that's your exponent. If these two bases are the same, your answer is simply going to be the argument of your exponent. So your answer is x. So if we have log base 7 of 7 to the 2x, oh, let's back up, we need an exponential. If we have 7 raised to the log base 7 of 2x, if these bases are the same, your answer is the argument, which would simply be 2x. Okay, next we're going to work through a few examples showing these properties. Okay, here we have a is 10 raised to the log of 4. Remember that if the logarithm doesn't state the base is 10. So this is the same as 10 raised to the log base 10 of 4. Since these two bases are the same, your answer is 4. Okay, let's move to C. Log base 7 of 7 to the negative 3x. Since these two bases are the same, your answer is the exponent, which would be negative 3x. Okay, E is e raised to the ln 20 power. Remember, ln means that the base is e. Since these bases are the same, your answer is simply the argument, which is 20. Okay, B and D are a little bit different because the bases do not match. If the bases don't match, you want to see if you can rewrite the argument to be a power of the base. So if you're looking at 25, can we write 25 as a power of 5? Is 25 a multiple of 5? And the answer is yes. So we can rewrite this as log base 5 of 5 squared. You're just going to rewrite it so that the bases are the same, raised to the x power. Now, when you have power over power, what do you do with the exponents? You multiply them. So that would give you log base 5 of 5 to the 2x power. Now your bases are the same, so your answer is the exponent of the argument, which is 2x. Okay, let's try that one again. Log base 2 of 64 to the x power. The bases are not the same, but you want to see if you can rewrite 64 to be a power of 2. So you'd have log base 2 of 2 to some power. 2 to what power is 64? You can go ahead and give that a try on your calculator unless you know it. That would be 6. Raised to the x power. Power over power, multiply the exponents. So that would be log base 2 of 2 to the 6x power. These bases are the same, so your answer is 6x. Okay, if you need to stop and rework this or write some of the questions down, try them on your own, go ahead and do that. Next will be your first lesson check. The lesson check is simplify 8 raised to the log base 8 of x power. Go ahead and write your answer down. When you're ready, move on to the next thing. Okay, the next couple slides we're going to be finding the inverses of exponential functions and then the inverses of logarithmic functions. I've broken them down into about 4 steps to help you out. Remember we said that exponential functions are inverses of logarithmic functions, and logarithmic functions are also in turn inverses of exponential. So if you're given an exponential term like we are right here, then your answer has to be a logarithmic equation if you're asked to find the inverse. So let's start with step 1, switch x and y. So if we switch x and y in our equation, we'll get x equals 6 to the y power. Okay, we did step 1, now step 2. Step 2 says isolate the power term. Now 6 to the y power is my power term. Isolate means to get it by itself. It already is by itself, so we can go ahead and move on to the third step. Now, if it wasn't by itself, it may look something like having minus 5. So before you could move to step 3, you would have to get rid of this minus 5 by adding x5 to both sides. Okay, but in this situation, it's already by itself, so we can move forward. Okay, step 3, write the logarithmic equation. Write as a logarithmic equation. So that means you need to identify your base, the argument, and your exponent. Okay, so that means I'm going to have log base, my base is 6, of my argument, which is x, is equal to the exponent, which is y. Okay, we wrote it as a logarithmic equation. Go to step 4. Solve for y. That means get y by itself. In this situation, y is already by itself, so you are finished. If it wasn't by itself, you would have something like y plus 8 equals log base 6 of x. You would have to get rid of this plus 8 in order to be finished. Okay, write those steps down. If you need to go through it again, go ahead and rewind. If not, here is your second lesson check. Example number 2, find the inverse of y equals 4 to the x power. Next, we're going to find the inverse of logarithmic functions. So the first thing you're going to do is the same. You're going to switch x and y. So that would give me x equals ln of y plus 3. Okay, the next thing you're going to do is isolate your logarithm. So, but if we look here, ln of y plus 3, since y plus 3 is in parentheses, that entire term is your argument. So our logarithm is isolated. If there was a plus 5 or minus 5 or something out here, or times, like 2 times ln, you would have to get rid of those first. So to isolate, you'd have to get rid of that plus 5. But in this given example, there is nothing else there, so we can move on now to step 3. Write as an exponential. That means you need to identify your base, which in this situation, since it's ln, that means your base is e. Your argument is everything in parentheses. That's going to be your equal to is y plus 3. And then remember, a logarithm, ln y plus 3, is always equal to your exponent. So if we write this in exponential terms, we're going to have e raised to the exponent, which is x, is equal to my argument, which is y plus 3. Now we need to make sure, step 4, that we solve for y and get y by itself. That means we need to get rid of this plus 3. So I'm going to subtract 3 from both sides. That means you're going to have e to the x power minus 3 is equal to y. Y is by itself, so then your answer is e to the x minus 3 equals y to the negative 1. Remember that the negative 1 is just notation stating that this is the inverse of y equals ln of x plus 3. Okay, again, if you need to go through that one more time, push pause and go back through it. If not and you're ready for the lesson check, here is your third lesson check. Find the inverse of y equals ln of x minus 5. Go ahead and work through that and then move on to the next thing. Okay, next we're going to graph the exponential function. And to do that, let's review we're actually going to graph logarithmic functions, but let's review graphing exponential first. So we know that when x is 0, to find our y-intercept, that our graph will cross right here at 0, 1. Okay, that'll be our y-intercept. And then as it moves to negative infinity, it's going to get infinitely close, and then it's going to shoot up here. Okay, so that is our exponential function. Remember that the domain is all real numbers. The range is y is greater than 0. Because our function is going to get infinitely close to the x-axis, but it will never touch or cross. Therefore, none of the negative y values will be a part of our function. The asymptote is y equals 0, which is your x-axis, because that is the line that our function will not touch or cross. Now, remember that when we talked about earlier, I'm going to change colors real quick. Inverse functions are a reflection over the line y equals x. So if we were to draw the line y equals x and take this function and reflect it over that line, that would be our logarithmic equation. So if we have log base b of x, that would be the inverse function. So remember, when we take inverse functions, we switch the x and y values. So instead of crossing at 0, 1, it's going to cross at 1, 0. So then it's going to get infinitely close here. Instead of it being the asymptote being y equals 0, our asymptote will be x equals 0, because we just switch our x and y. And then it's going to grow up here like this. So you can see how those are reflections of each other. And then all of the domain, the range, and the asymptote just switch. So our domain is going to be x is greater than 0 instead of y is greater than 0. And our range will be all real numbers. Okay. So on the next slide, we're going to go through how to graph a logarithmic equation. Go ahead and write the steps down. Okay, so the first thing we're going to do is convert your equation to logarithmic. Okay, so the first thing we're going to do is convert to exponential. So the base, y equals log base 3 of x. My base is 3. My exponent is y, because the logarithm is always equal to the exponent. And that's equal to x, which is the argument. Now, the next thing you're going to do is make a table, which you have done several times. You know how to make a table, x and y. Typically, we choose our domain to find the range. But since we are solved for x instead of y, we're actually going to choose y to find x. So that's kind of a little different thinking than you're used to. So we're going to choose y to find x. So that means we're going to substitute negative 2 in for y. So that would give you 3 to the negative 2 equals x. So 3 to the negative 2 power means reciprocal of 3 squared. So that would be 1 over 9. So that means when x is 1/9, y is negative 2. Okay, let's do negative 1. 3 to the negative 1 means the reciprocal of 3 to the first power. So that means x is equal to 1/3. So when x is 1/3, y is negative 1. Okay, 0. 3 to the 0 power is x. Anything to the 0 power is 1. That means when x is 1, y is 0. So we could graph that point here. 1. 3 to the first power is 3. So when y is 1, x is 3. So we're going to graph the point 3, 1, and then let's do the last one. 3 to the second power is x. That means when y is 2, x is 9. Okay, so we're still going to graph normally when x is 1/9, y is negative 2. So we're barely over, so we're really getting infinitely close to the y-axis. When x is 1/3, y is negative 1. When x is 1, y is 0. When x is 3, y is 1. When x is 9, y is 2. So you can see that it's going to get infinitely close here and then grow as we head towards positive infinity. My domain is x is greater than 0. My range is all real numbers. Your asymptote is x is equal to 0. Okay? When you're graphing and you just have a few points, it's really important to know what your function is supposed to look like. And so if you know you have a logarithmic equation, you have to know that it's going to continue to infinity on both sides. So you have to kind of have a good idea of what your function is supposed to look like so that you'll know where you're supposed to start and stop, or if it continues on throughout infinity. Okay, again, if you need to watch that again, work through it, or write the question down, try it on your own. Make sure you know how to list the domain, range, and your asymptote. Okay, we have one more lesson check. This lesson check is example 4. List the domain, range, and asymptote of the function f of x equals log base 5 of x. Okay, you guys, this is the last week of new information that we'll be working on. You will have a test on Friday on chapter 4, and then after that you'll have time next week to make up what you need to and work and prepare for the final. So good luck. Make sure you do your lesson check.